All right, so if you've ever been in the trenches of a machine learning project, you know it can get chaotic fast. You've got dozens of experiments, countless parameters, different versions of code floating around. It's a real headache. Today, we're going to break down MLflow, the open source platform that was literally designed to tame that chaos and bring some much needed order and reproducibility to the world of ML. So here's our game plan. First, we're going to really dig into that ML chaos I just mentioned. Then, we'll see exactly how MLflow steps in as the solution. We'll take a tour of its 4 core components, what they call the 4 pillars. After that, we'll see how it's being used in the real world. And finally, we'll talk about where it might fit into your MLOps strategy. Okay, so to really get why a tool like MLflow is so important, we have to start with a problem, right? Let's dive into the core challenges that made something like this an absolute necessity in the first place. This question right here, it's the one that keeps data scientists up at night. You finally, after hundreds of runs, get that amazing result. But then trying to figure out the exact combination of code, data, and hyperparameters that got you there feels like a full-blown detective investigation. This single pain point is right at the heart of the whole MLOps challenge. And before platforms like MLflow came along, this was the painful reality. Think about it. Experiment management was a mess of spreadsheets and file names. Reproducibility? You were constantly battling the infamous, well, it works on my machine problem. Every deployment was a custom, one-off job. And model governance? There was no single source of truth to manage anything. It made scaling projects from a cool notebook idea to a real production system incredibly hard. All right, so we've painted a pretty messy picture. Now, let's talk about the solution. Let's see how MLflow's core philosophy is designed to bring some sanity to all of this. Now, the key thing to grasp about MLflow is what it's not. It's not some super rigid, one-size-fits-all system that forces you to change everything. Instead, think of it more like a flexible, open layer that sits on top of your existing workflow, making every single step, from that first experiment to the final deployment, traceable and reproducible. And this right here, this is why so many people love it. The whole philosophy is simple. MLflow should work for you, not the other way around. You can use whatever ML library you want, you barely have to change your existing code, and it scales effortlessly from your laptop all the way up to a massive cluster. That flexibility, that commitment to imposing as few constraints as possible is its secret weapon. Okay, so that's the big idea. But how does it actually work? Well, MLflow is built on 4 distinct but tightly integrated components. Let's take a quick tour of these 4 pillars. This table breaks it down perfectly. Just look at the direct line from the problems we talked about to the solutions each pillar provides. MLflow tracking solves the experimentation mess. MLflow projects tackles code portability. MLflow models gives you that desperately needed deployment consistency. And the model registry provides the governance layer to manage the whole lifecycle. Let's quickly touch on each one. First up, the foundation, MLflow tracking. Honestly, the best way to think about this is like a super-powered digital lab notebook for all your experiments. With just a couple lines of code, you can log your parameters, your metrics, and even save the model itself. But where tracking really shines is with teams. Once everyone starts logging to a central server, you're no longer working in silos. It becomes this transparent, collaborative effort where, as the quote says, everyone can team up to try to beat the current best benchmark. That's a huge culture shift. Next up, MLflow projects. This one is all about solving that classic, infamous problem, but it works on my machine. It gives you a standard way to package up your code so that anyone on any machine can run it and get the exact same results. And the way it does this is actually pretty simple, but brilliant. It just has you define all your code's dependencies in a straightforward file, like a conda.yaml or a Docker file. That's it. That little file is the key to guaranteeing true reproducibility across your entire team. Then we have MLflow models. If projects is about making your code portable, models is about making your models portable. It packages your trained model in a universal format, so you're not locked into one specific tool or deployment platform. The secret sauce here is this amazing concept called flavors. When you save a model, MLflow doesn't just save it one way. It creates multiple versions or flavors at once. You might get a native tensor flavor for high performance, but you also get a generic Python function flavor, or PyFunc. And that PyFunc is your golden ticket. You can deploy it almost anywhere, as a REST API, on SageMaker, on Azure, you name it.
And that brings us to the final pillar, the MLflow model registry. If the other components are about creating and packaging, this is all about managing and governing. It's the central library, the single source of truth for all your production-worthy models.
So what does that actually look like in practice? It means you get this beautiful, clean handoff. A data scientist can promote their best model to staging, and the DevOps team then knows exactly which version to grab and deploy. It turns what used to be a messy, error-prone back and forth into a smooth, streamlined workflow.
Okay, so that's the theory, but what about the who? Where is MLflow actually making an impact out there in the real world, and how is it keeping up with the insane pace of AI?
Yeah, that number is pretty staggering. We're talking over 5,000 organizations worldwide. And this isn't just one niche industry, it's across the board. Finance, retail, healthcare, telecom, you name it. Let's take a super critical example, financial services. In an industry this heavily regulated, you can't just say, I think this model is right. You need a full audit trail. You need to be able to prove exactly what data, what code, and what parameters created that risk model. For them, that's not just a nice feature, it's an absolute necessity, and MLflow delivers that.
And what I think is really cool is that MLflow isn't just standing still. As the world goes all in on generative AI, it's evolving right alongside it with tools for LLM ops. We're talking about features for tracing the complex steps of AI agents, a UI built specifically for prompt engineering, and even automated evaluation, where you can use one powerful LLM to judge the output of another. It proves the platform's core ideas are ready for whatever comes next. All right, let's get to the big question, the one you're probably asking yourself. With all the MLOps tools out there, where does MLflow actually fit? Is it the right choice for your team and your strategy?
So let's do a quick head-to-head with another open source giant, Kubeflow. And really, they're coming from two totally different places. MLflow is all about being lightweight, flexible, and super easy for data scientists to just pick up and use. Kubeflow, on the other hand, is a beast. It's a much more complex, all-encompassing system built on Kubernetes, really geared towards teams that have serious DevOps skills.
Now, what if we compare it to a fully managed cloud service like Amazon SageMaker? Here you see that classic trade-off, right? With open source MLflow, you get total freedom. No vendor lock-in, you control everything. The catch? You are responsible for managing it. A service like SageMaker takes all that management pain away, but in return, you're living deep inside the AWS ecosystem. And all of this really leads us to one final fascinating question about the future. Because MLflow is so modular, it can be the simple, powerful center of your MLOps universe, or it can just be one specialized component in a much larger toolbox. So what's the future of MLOps really going to look like? Are we heading towards one single platform that rules them all? Or is it more of a best-of-breed world where we stitch together the best tools for each specific job? The beauty of MLflow is it's built to thrive in either world.